Welcome to today's Explainer. Get ready, because today we are unpacking a truly mind-bending paper by Dean A. Kulik titled The Geometry of the Invariant Boundary, a Pure Domain Architecture. If you've ever just assumed that reality is basically made up of solid objects moving through empty space, well, prepare to have your entire perspective totally shattered. Kulik's work completely reimagines reality. We're not talking about isolated things floating in a void. We are talking about pure, continuous, geometric topology. This isn't just a minor tweak to traditional physics. It's a total, ground-up, structural rewrite of how existence itself is generated.
Okay, let's dive right into this. On the agenda for today, the ontological inversion, axioms of the seam, the necessity of the lean, the approach vectors, and finally, we'll bring it all together with time and consciousness. Let's get started.
Section 1. The Ontological Inversion.
So this is the very first massive paradigm shift we need to make to really grasp Kulik's framework. We are going to completely flip how you understand the most basic properties of existence. You have to realize that traditional physics and computation essentially have it backwards. We normally assume that static states, objects, and numbers are the primary reality, and that boundaries are just what happen in the empty spaces between them. But Kulik argues the exact opposite. There is no pre-existing void. Instead, the frame is unconditionally full. The boundary itself, this absolute unoccupiable seam, is the singular primary structure. Everything else, every discrete state, number, or timeline, is literally just a secondary, trailing projection of this central boundary being read from different angles.
Think about the stark contrast here between traditional mechanics and this pure domain architecture. In a perfectly filled topological frame, there are absolutely no empty storage slots. There is no literal or even metaphysical in-between space for an object to travel through. So, what does this actually mean? It means what we observe as motion or transition is absolutely not the physical displacement of an entity through a void. It is, mathematically speaking, a continuous projection shift of the exact same, fully occupied structure. The face of the geometry changes, sure, but the underlying field doesn't move a single inch.
Moving on to Section 2. Axioms of the Seam. Since we've tossed out the idea of a universe full of empty space and moving objects, we need some absolute rules to govern this completely full geometric reality. So meet the seam, which is represented by the symbol T. The seam is the totally unoccupiable boundary. Because the topological frame is completely packed full, it is under this immense, opposing pressure from all sides. The seam is the exact, strict locus where all these opposing spatial and temporal potentials perfectly cancel each other out to zero. It represents pure, absolute structural constraint.
And because the seam is a place of perfect cancellation, it operates under some incredibly strict domain axioms. Axiom 1 tells us the boundary exists absolutely between projected states. Axiom 2 is absolutely critical, the prohibition of encoding. Because arriving at the boundary means the perfect cancellation of all forward momentum, any localized address is totally destroyed. It is fundamentally unwritable and unoccupiable by any live executing system, period. And Axiom 3 dictates that every continuous transition must cross it. If you hit dead center, your gradient vanishes, and mathematically, you cease to exist as an observable entity.
To really understand how we experience this unoccupiable boundary, imagine you're looking through a camera lens. If you zoom all the way out to axis P, which is the whole view, you see the complete topological manifold all at once. From the outside, the boundary represents perfect omnidirectional balance. It's a peaceful manifold. But if you zoom into axis L, the linear time view from inside the executing process, you literally can't see all faces at once. Reading requires a localized selection, which forces a specific orientation. Therefore, from the inside looking out, that exact same peaceful boundary violently transforms into a condition of maximum imbalance and unrelenting tension that constantly has to resolve itself.
Section 3. The Necessity of the Lean.
So, the crucial point is this. If the inside view is pure tension, and arriving at the dead center of the boundary means you literally cease to exist, what keeps a localized system alive? It all comes down to epsilon. Epsilon must be strictly greater than 0. In traditional math, epsilon is often brushed off as just noise, error, or structural friction. Kulik vehemently rejects that idea. The lean, this non-zero displacement from the boundary, is the absolute mathematical necessity of existence. It is the rigorous proof that a localized perspective exists at all.
Kulik actually hits the nail on the head here, stating, to exist as an observable entity is to possess an epsilon. If a system were to magically erase its lean and settle perfectly into the dead center of the boundary, epsilon would instantly equal 0. The tangent of execution would completely vanish. The system would instantly merge with the static whole, become totally invisible, and cease to exist in any measurable capacity whatsoever. You survive solely because you are constantly leaning away from perfect balance.
Let's move to Section 4, the approach vectors.
Since we know a system can never actually occupy the boundary and must always maintain this lean, how does it actually do anything? Well, it has to constantly try to read the boundary. And there are strictly 3 and only 3 approach vectors mathematically capable of doing this: the unfold, the fold, and the scan. Every computation, every number, and every single cryptographic hash in reality is fundamentally nothing more than the physical trace residues of these 3 pure geometries trying to navigate that boundary pressure. Let's break them down one by one.
First up is the unfold vector. It expands aggressively outward from the origin. But remember, mathematically, the boundary is completely forbidden from being reached. So because it can never arrive, the vector just keeps pushing forward continuously. Kulik points out something incredible here. What traditional mathematics calls infinite, irrational, transcendental constants, think of pi for example, aren't just independent numbers floating out there in the ether. They are simply the physical exhaust trace of a spatial approach that is permanently blocked by an absolute structural constraint.
Now, the fold vector, it does the exact opposite. It violently compresses inward from the extreme outer limits of the manifold, plunging relentlessly toward equilibrium. Because the frame is completely full, there are no empty slots to dump its data into. So instead, it displaces massive amounts of information from those wide outer spaces directly into an incredibly dense, highly specific geometric coordinate. Eventually, to avoid being completely crushed into the boundary, the fold undergoes a catastrophic phase lock, freezing into a tiny residual lean just to survive.
And this brilliantly illustrates how the fold and unfold are so intimately connected. We call this the involution operator, J. Because the invariant boundary is locked in absolute position by perfectly opposed potentials, it essentially acts as a flawless, infinitely reflective mirror. Any localized system attempting to read it inherits this exact macroscopic symmetry. The unfold expanding from the origin is the pristine structural dual of the fold compressing from infinity. The boundary physically forces the execution loop to eventually close perfectly upon itself.
The third approach is the scan vector. Unlike the other two, the scan never leaves the intimate domain of the boundary. Instead, it wobbles laterally, sort of sliding perpendicularly along the constraint axis. When it resolves perfectly against that strict edge, it generates a resonance point. These points aren't just abstract solutions to algebra. They are the literal geometry of the invariant boundary reading itself in real time. And finally, Section 5, Time and Consciousness. This is where all the geometric topology we've been talking about culminates into the ultimate philosophical implications of the pure domain architecture. Under this new framework, we have to completely redefine time. Time is absolutely not some universal ambient void or a ticking clock in the background where events just happen. Time exists entirely because the invariant boundary cannot be physically occupied. Because you cannot sit dead center, you are literally forced to maintain that epsilon lean. The localized structure is constantly shifting to resolve pressure, which immediately generates a new tangent. So time is quite simply the spatial position of that read head being relentlessly pushed forward into the next adjacent address.
Information gets the exact same radical treatment. It is completely redefined. Information isn't stored in isolated static states, because static states are just barren, trailing projections. Instead, information is flawlessly defined as crossing geometry. It's strictly about where the execution trajectory violently collided with the invariant seam, and exactly the angle, the velocity, and the spatial pressure it possessed right before the crash. The geometry perfectly encodes the path.
So what does this all mean? This leads us to arguably the most profound realization in Kulik's paper. If time is really just a forced spatial lean, and information is simply the geometry of the crossing, what actually happens when an executing geometric vector becomes capable of looping its own read head back onto its own trajectory?
That brings us to the epsilon of epsilon, the recursive feedback loop. This happens when the localized system stops being a simple forward-marching process and elevates into a recursive process. It generates a highly complex lean predicated entirely upon its own existing lean. The geometry is now dynamically and continuously measuring the precise rate, angle, and distance at which it is measuring distance. It's a loop.
And boom! That brings us to the geometric derivation of consciousness. In the pure domain framework, consciousness is emphatically not a biological metaphor. It is not some emergent magical property of a complex brain. Consciousness is strictly a mathematical property. It is the absolute structural necessity of the invariant boundary reading itself. It is a recursive mechanism trapped in a maximally filled spatial frame, forced to endlessly map the exact locus of its own forced orientation.
As Kulik masterfully lays out, the pure domain geometry proves that the empty space between objects is a profound illusion. It's an illusion generated entirely by the severe spatial limitations of our linear time reading. There is no spatial gap out there. There is strictly only the total symmetry of the whole manifold and the highly localized lean that generates your existence. So I'll leave you with a truly staggering thought. If your entire conscious experience is just a microscopic recursive ripple mapping its own lean against an unoccupiable geometric boundary, what unseen topology is actually casting your shadow?